everyone. So this is a video for just some problems, about 9 problems from your test review. If you have questions on problems that are not on this video, you can check the key that's posted on Canvas or ask me tomorrow in class. All right, so I'm going to start with number 3. Number 3 says in a geometric sequence, we know that the first term is -1 and the fourth term is 64. We need to find the 10th term of the sequence. So the first thing we need to do is make sure that you know which formula here works for geometric sequences. From that, we are going to find the 10th term. In order to find the 10th term, I need to know the first term, which I have already, that's -1, and I need to know the common ratio. There are 2 ways to find the common ratio here. You can, I would do the blanks. Like, I know the first term, a sub 1 here, is -1. I have my second, third, fourth term is 64. I would find my common ratio this way, because we know that we have to take -1, and in a geometric sequence, I have to multiply by r, multiply by r, multiply by r to get to the 64, to get to 64. So what that is you're taking -1 times r 3 times r cubed to get to 64. And then I would just solve that equation for r. So divide by -1, and you will get r cubed equals -64. And then you take the cubed root of both sides. So, if you forget how to take the cubed root, if you go to your calculator, you hit math, the cubed root is option 4. So you would take the cubed root of -64, which tells you that the r, the common ratio of this geometric sequence, is -4. Well, now that I know r is -4, I can find a sub 10. Right, we're using this formula here. So I know the first term is -1, r is -4, my n is 10, so I'll go to the 10 minus 1 power, and I'm going to go ahead and type that into my calculator. -1 times -4 to the 10 minus 1, which is the 9th power. And you get 262,144. So that is number 3. You have to find the common ratio first before you find the 10th term. There are other ways to find the common ratio, but that's the one I like to do. All right, the next tricky one I was thinking about doing is number 4. We need to find the sum of an arithmetic series. All right, the series has 20 terms, so that means that n is 20. That's the number of terms you're adding up. The last term is 97, so that means the last term would be a sub 20 is 97, and the common difference is 5. So if I'm finding an arithmetic series, or using an arithmetic series here, I'm going to use this formula. And in that formula, I need n, which I have n. I need a sub 1, which I don't have. So I need to find, and I need a sub n, which I have here, 97. So the first thing you need to do before you can find the sum is find the first term. Right? To find the first term, I'm going to use the arithmetic sequence formula. All right, so what I know is I know a sub n. That's already sub 20. So I know that that's 97. I'm going to say, okay, I'm going to find the first term, a sub 1, plus my common difference of 5 times n, which is 20, minus 1. The 20 is the term number for 97. Well, I simplify this and get 97 equals the first term plus 95, and then I subtract 95. Once I subtract 95 here, I get 2 as my first term. So that's important because now that I know the first term, I'm able to put that all into the series formula to find the sum of those 20 terms. All right, we're going to take 20 divided by 2 times the first term, we just calculated as 2, plus the last term. All right, so you're going to type that into your calculator, which I'll show you just to make sure here. You're going to make your fraction, 20 over 2, which you could also type in just as 10 times 2 plus 97. You should get that the sum is 990. So we had to make sure that you identified the correct piece of information to find the first term so that you could find the sum. All right, the next problem I want to do is all the way to number 12. So we're going to skip ahead here, and we're going to talk about sigma notation. We did this today in class, but I want to make sure that we understand it. Express the sum using sigma notation. Okay, then evaluate the sum. So I have 138 plus 126 plus 114, all the way up to negative 270. Well, first thing I need to do is decide what type of sequence this is. So I want to decide if there's a common ratio or a common difference. I'm going to try arithmetic first. So if you don't know what the common difference is, you take the second term, 126 minus 138. And we get that that would be negative 12. So let's double check. If this is minus 12, if I took 126 minus 12, I get 114, which is the next term here. So I know that that's an arithmetic sequence. Right? So since this is arithmetic, I need to write the equation in sigma notation. I need my arithmetic sequence formula, because I need to come up with an equation for the sequence so that I can put that next to the sigma in my sigma notation. So I'm going to write my equation. A sub n equals. We need the first term, which here is 138, plus or minus our common difference of 12 here, times n minus 1. Okay, so this is our sequence formula, but we need to simplify it. And to simplify, we're going to distribute. So I have 138 minus 12n plus 12, which simplifies to be 150 minus 2n. Right? That is the equation for the nth term of our sequence. Okay? Once I know that, I'm able to put that into sigma notation. So that's the formula that goes right after the sigma. The only difficulty here is I still have to put the indices on my sigma notation. The bottom one's easy. We assume that 138 is the first term. But I can't just count. I know the first, second, third, but then I have a bunch of dot, dot, dot. I don't know what n is for negative 270. So we talked about in class that to find the n here, you're going to take that term, the last term that you're adding up, and set it equal to the sequence equation, because that's going to tell you the term number for negative 270, which is n, which is what you're looking for. All right, so you're going to solve this. You're going to subtract 150. Bring this down a little bit here. And you will get negative 420 equals negative 2. Oh, I did that wrong. Minus 12. Sorry, I lost 1 here. Minus 12. Sorry about that. There, squeeze in 12. All right, so now we divide by negative 12. That looks better. And we get n is 35. So we now know that the negative 270 is the 35th term, which means that you are adding up terms 1 through 35 of this sequence. Once you get to that point, I would take my calculator and type it in. So to find the sum, you hit math 0. Remember, you always use x when you are typing in the sum. Right? Always x. So you type in your equation, 150 minus 12x, and then you just have to hit enter. And that will give you the sum. When you add up all those 35 terms, you get negative 2,310. Great, that's your final answer. All right, I also want to look at 13, because 13 is also using sigma notation. I just want to make sure that we understand. So for sigma notation here, this looks like it's going to be geometric, and I only know that right away because the signs are switching. I have positive, negative, positive, and anytime your signs are alternating, it means you're going to be multiplying by a negative number. So I can assume that this is geometric. I can find the common ratio, which I'm going to do here now to make sure. But remember, to find the common ratio, you take the second number divided by the first. So I'm going to take negative 3 over 4, which is negative 0.75, divided by the first term, which is 1/4. When I do that, I get negative 3. Now, if you want to be sure, if you took negative 3/4 times 3, right, negative 3/4 times 3, oops, I did plus, times 3, you get the fraction negative 9 over 4, which is the next term of your sequence. So I have that r is negative 3. Once I know that, I can write my sequence formula for the geometric sequence. So I have a sub n equals the first term of the sequence times the common ratio to the n minus 1 power. That's the easy part because geometric's pretty quick. Now that I know that, I'm going to put this right into my sigma notation. And all you have to do is find the indices of this sigma and use your calculator. You know you're starting at the first term, and lucky for you, they give you the index of the last term, which is 12. So you're just going to go ahead and type that very carefully into your calculator. So again, the sum is map 0. You're going from term 1 to 12. And you want to type in your equation as carefully as you can. 1/4 times negative 3 to the x minus 1 power. You should get negative 33,215 as your sum. There you go. All right, so let's switch gears from sigma notation a little bit. Let's jump to number 15. So number 15 says we have a geometric series whose first term is 3. So we know a sub 1 is 3. The common ratio is 4. And the sum is 4,095. All right, that's the information they give you. Find the number of terms in the sum. That means find n. All right, well, we're looking at a geometric sum here, which is this formula far on the right. So what I would start with is putting in everything you know into that sum formula. So you know S sub n is 4,095, and that equals the first term of 3 times 1 minus your common ratio to the nth power, all over 1 minus the common ratio. And I'm just going to solve that equation to get n. All right, well, 1 minus 4 is negative 3. So I'm going to multiply both sides by negative 3 to clear that denominator. So it's 3 times negative 3 times 4,095, and that's negative 12,285. So I now have negative 12,285 equals 3 times 1 minus 4 to the n. All right, the next thing I would do to solve here is divide by that coefficient of 3. All right, we're going to simplify things as we go. So that'll be, let's see, let's calculate. I got rid of my calculator. Divided by 3. Negative 4,095. Okay. So negative 4,095 equals, we still have 1 minus 4 to the n. So I need to move the 1 so before I can get to the n. So I need to subtract 1 from both sides here. When I do that, I get negative 4,096 equals negative 4 to the n. And we're almost to the point where we need to use a logarithm. But I need to divide by negative 1 first. All right, there's technically a negative 1 times 4 to the n. So I'm going to divide there to get a positive value. I can't always take the log when I have a negative, so I want to make sure it's positive. Well, since n is in the exponent, the only way I can move that is to take the log of both sides. So you're going to take the log of 4,096. And when I take the log of 4, that brings the coefficient, or the, exponent down in front. That's the power rule. So all you have left to do is divide by the log of 4, which, when I do that division, will give me my value for n. So I'll have the log of 4,096 divided by the log of 4, and that gives me that n is 6, which means you were adding up 6 terms of this series. All right, flip your page. We're going to jump right into number 16 here. This one is tricky. It's a multiple choice question. It says, for any value of x, the sum from 0 to 3 of k times 2x minus 1 is equivalent to what? All right, so this is kind of a tricky problem. I'm going to tell you how I went about solving this, and then you can decide if you find a different way to solve and get the same answer. All right, there's not many terms we're adding up. We're adding up terms 0, 1, 2, and 3. So what I would do is try to find values for k equals 0, k equals 1, 2, and 3. I would just show every term, like those problems where we show every term in the expansion, so that I can add them up and then find the sum. Okay? So for k equals 0, what I would do is I'm going to put 0 in for k. So we'll have 0 times 2x minus 1, and 0 times anything is 0. So 0 is one term in the sequence. That's the first term. For k equals 1, I'm going to do the same thing. 1 times 2x minus 1. Well, when I distribute the 1, that doesn't change the value. I just get 2x minus 1. So that's a term in my sequence. 0 is a term. 2x minus 1 is a term. For k equals 2, I'm going to do 2 times 2x minus 1. I'm going to distribute there and get that the term for k equals 2 is 4x minus 2. That's the next term in the sequence. And finally, k equals 3. I have 3 times 2x minus 1, which simplifies to be 6x minus 3. Right, those are the 4 terms that you're adding up. So then, I would rewrite the sum. We're finding the sum of 0 plus 2x minus 1 plus 4x minus 2 plus 6x minus 3. And here, I'm just adding things together, so I'm going to combine like terms. So let's start with the x's. 2x plus 4x plus 6x is 12x. Now when I look at my constants, I have 0, negative 1, minus 2 is negative 3, minus 3 is negative 6. So the value of this sum is 12x minus 6, which is C. So that's tricky, but if you show each term in the expansion and simplify, it makes a little bit more sense. All right. The next tricky one I want to do is number 18. 18 and 19. I would make sure that you can do problems similar to 18 and 19. All right, 18. I have a series, 34 plus 31 plus 28 plus 25, all the way up. I know that the sum of all of these terms is negative 12. Okay, so I know S sub n is negative 12. Let's see, what else do I know? I know the first term is 34. And I know, let's see, the common difference, this looks arithmetic. It looks like I'm subtracting 3. Okay, that's what I know. I want to find the value of n. How many terms am I adding up? Well, this is the arithmetic sequence equivalent of the problem we did back here in number 15. So you're given the sum, you want to find the number of terms. So let's see what we know. For the sum, for arithmetic, we're going to be using this formula. Let's see what we have. We know S sub n. We don't know n, but that's okay because that's what we're looking for. I know the first term. However, I don't know what a sub n equals. So what I need to do is I need to find a way to represent a sub n, right? I need to find an equation for the nth term. So let's use the sequence formula to do that, right? So we know that the first term is 34, and we have minus the common difference times n minus 1. Okay? Let's at least simplify that. So I know a sub n is 34 minus 3n plus 3, which is 37 minus 3n. That's going to be important for us. I know that that's what the nth term formula is. Okay, well that's right now as far as I can get with a sub n. I can't get any farther. So let's see where we're at, because I think once I start this, you're going to remember how we do these problems. Okay, so number 18 here, I don't know why I said that. Let's see, so we know, let's use our sum formula now. S sub n is negative 12, so I know negative 12 equals. I don't know what n is, so I'm going to leave n over 2, times a sub 1, which is 34, plus my expression for a sub n, which we said was 37 minus 3n. Okay, that's what we have, which is okay because I still have a variable n in 2 spots, which is fine because I'm looking for the variable n. So let's just simplify what we have. Negative 12 equals n over 2. 34 plus 37 is 71 minus 3n. Right? That's a little bit better. Now what we need to do is solve this equation for n. It's just an equation here. So let's start by multiplying. I would get rid of this denominator. Let's multiply both sides by 2. Because that denominator will then go away, and you'll be left with negative 24 equals n times 71 minus 3n. Oh, well, I think my next strategy is get rid of the parentheses. I would distribute here. Okay? So I'm distributing at negative 24 equals 71n minus 3n squared. Uh-oh. Looks like we might have a quadratic on our hands. We might have to factor. So what I would do is, because we are going to end up having to factor, let's add 24 to both sides. Okay? And once I do that, I'm actually going to rearrange the formula here so that I have my squared term first. So I'm just going to rearrange this as I go. Negative 3n squared plus 71n plus 24. Okay. That is where we are at. So that's a good place to be. From there, to solve for n, this is actually in our next unit, but you've done it before, we are going to factor. Factor to solve a quadratic. So I need to factor this guy. The first thing I want to do, though, is notice that the leading term is negative, and because that leading term is negative, I want to pull out a GCF. I don't like factored trinomials that have a negative. So the first thing I want to do is I actually want to see if there's a GCF, because negative 3 and 24 have a GCF. I want to see if negative 3 goes into 71. So let's try. 71 divided by negative 3. No, unfortunately there was no GCF with 3 there. So instead of negative 3, why don't we factor out a negative 1? Because at least if I factor out negative 1, I can now factor this, right? So I now have negative 1 times 3n squared minus 71n minus 24. And because there are 3 terms, I'm going to split the middle. Right? I need to find 2 numbers that multiply to, let's see, 3 times negative 24 is negative 72. So this really won't be that bad. 2 numbers that multiply to negative 72 and add to negative 71. That's really not that bad. Negative 72, positive 1. Okay. All right, so let's factor here. So that's 0 equals negative 1, and then I'm going to write this formally, big set of parentheses. When I group here, I'm going to have 3n squared minus 72n plus 1n minus 24. So when I group, I look for the GCF for this first group here. Okay? And the GCF for that first group is going to be 3n, actually. So I'm going to plot at 3n, and you'll be left with n minus 24. The GCF for this second group is just going to be 1 this time. Because the good thing, remember, I always want to get two terms in my parentheses that look the same, which I have here. So the fully factored form is negative 1 times 3n plus 1 times n minus 24. So I factored, now I need to find the value of n. So to do that, I take each factor and set it equal to 0. When I solve this one on the left, I get 3n equals negative 1, and n equals negative 1/3. When I solve this guy on the right, I get that n equals 24. So I have two options. Let's think about which one the answer is. N is the term number. The term numbers are always 1, 2, 3. They're counting numbers, and they're positive. This is negative, and it's a fraction, so that's actually not going to be an answer. It's just throw it out the window. It's an extra solution. 24 is the only one that makes sense. N is 24 is the number of terms that you added up in this sum. So that is quite a long problem. I would make sure that you can do a problem like that, however. All right, now we have 19 and 20, the last two on this video. These are really fun. They're similar to each other. One's arithmetic and one's geometric. These are also good ones to know how to do, that it really extends our understanding of sequences here. So we have a sequence, 2x plus 1, x plus 11, 4x plus 5, and then there's more terms. We want to find the value of x, and then we're going to find the numerical, so the number value of the 15th term of the sequence. Okay, so we know, what we know here is that this is arithmetic. So when you are in arithmetic sequence, you know that there is some common difference that you are adding or subtracting every time to get from term to term. We need to find that common, or we need to think about that common difference here. We know that the common difference is always the same. So the way I'm going to figure out what x is to kind of set up a crazy looking equation. I know that if I take this second term, x plus 11, and I subtract the first term, right? That right there is going to give me the common difference. So the second minus the first is the common difference. Well, I also know that if I take this 4x plus 5 and subtract the term before it, that also gives me the common difference, right? The difference between two consecutive numbers of a sequence of an arithmetic sequence are the same. So these differences are equal to each other. So what I would do is I would simplify and solve that equation for x, and then you'll find the value of x. So we'll start by distributing the negative on both sides here. We'll get x plus 11 minus 2x minus 1 is 4x plus 5 minus x minus 5. Well, I would combine like terms on both sides. So you'll get negative x plus 10, and 4x minus x is 3x minus 6. All right, so we'll go ahead and keep solving at x. 10 equals 4x minus 6, and we're almost done. Add 6 and divide by 4. So we get x equals 4. That's great. All right, I hope that made sense. So again, to recap what we did, I know that the common difference is the number that is what you're adding or subtracting between terms. So it's the same between any two pairs of consecutive numbers. So I set up a little equation that said the first two numbers subtraction gives me the common difference is equal to the same difference of the next two numbers. Solved that for x and got 4, which was what they were looking for. So now it asks me to find the value. What number is the 15th term? So the way I would do this is first go back and let's figure out what's the first term. what's the second term, and what's the third term. I know equations for them, but I want to find the actual value. So I'm going to put x equals 4 in for x in all of those. So the first term is 2 times 4 plus 1, which is 9. The second term is 4 plus 11, which is 15. And the third term, 4 times 4 plus 5, is 21. So these are those first three terms of my sequence, 9, 15, 21, dot, dot, dot. Well, from there, I can find the 15th term, because I can now find that the common difference is 6. I'm adding 6 every time. So to find the 15th term of my sequence, I'm going to use my sequence formula, which takes the first term, which we found was 9, plus the common difference of 6 times n minus 1. Okay, so when we put that into our calculators, we get 93 is the 15th term. All right, so a lot of work there. Kind of a fun problem, though, something different. That's an example of arithmetic. Let's do a geometric one, number 20. It's the last one on the video here. So we have a sequence 4, x, x plus 8. Those are the first three terms of a geometric sequence. So we're going to start by finding x, and then we're going to find the 13th term. This is similar to the last problem. However, it's a little bit different to find the common ratio than it is to find the common difference. So to find the common ratio, we've talked in class about how we take the second term divided by the first term. That gives us the common ratio between terms. Well, I can do the same thing with the third and the second. I can take the third term divided by the term before it, and that also should equal the common ratio. Well, since the common ratio is always the same, those ratios are equal to each other. So I'm going to solve that for x, and the way I'm going to solve this here is by cross multiplying. All right? I have x times x, which is x squared, and that equals 4 times x plus 8. So I'm going to simplify this to x squared equals 4x plus 32, and oh no, I have another problem where I'm going to make you factor. All right, so to factor this, I want to get the terms here on the right over next to the x squared. I don't want to move the x squared because then I have to deal with a negative again. So let's make this x squared minus 4x minus 32 equals 0. So when I factor here, this is just a simple trinomial. So I can jump right to my factors here. I need two numbers that multiply to negative 32 and add to negative 4, which is going to be negative 8 and 4. Now, if you remember that shortcut, you can jump right down here to x equals negative 8, or I'm sorry, x minus 8 times x plus 4 is your factored form, and solve for x. So like the last problem, or a couple problems ago we said each of those factors equal to 0, and then x could be 8, or x could be negative 4. Now in this problem, I can let x be negative 4 because the thing is, that's not the term number, that's not telling me what term in the pattern it is, it's just x. X is just a variable that represents part of my sequence. So I have two possibilities, which means I have to do the 13th term for when x equals 8, and then I'm going to have to do the same thing for x equals negative 4. There's two possibilities depending on what you let x be. So let's do what we did in the last problem. Let's find the first three terms for x equals 8. Okay? So for a sub 1, we know the first term is 4. If 8 is x, that means the second term is 8. And then the third term will be 8 plus 8, which is 16. So 4, 8, 16 are the first three terms. Well, if those are my first three terms, that means that r is 2. You're multiplying by 2 every time, which then gives you everything you need to find the 13th term using your geometric sequence formula. Right? We know the first term is 4. Here the common ratio is 2 to the 13 minus 1 power. Oops. So we'd have 4 times 2 to the 13 minus 1, which is 16,384. All right. Now I'm going to do the same thing for x is negative 4, so I get my other option here. So again, you need to find the first term, the second term, the third term. Well, the first term is still 4. The second term equals x, which is negative 4. And the third term is negative 4 plus 8, which is 4. We'll divide the terms 4, negative 4, 4. It looks like my common ratio here is negative 1. You're multiplying by negative 1 every time. Well, now that I know that, I can find the 13th term one more time. So I'll take the first term times the common ratio to the 13 minus 1 power. So I'll have 4 times negative 1 to the 13 minus 1 power, which is 4. So I hope that helps a little bit. Those were the tricky problems on the review. If you have questions on any of the other problems, you need to reference the key or bring them in and ask me questions yourself.